LeetCode 2096 step-by-step directions from a binary tree node to another. So we are given a tree, binary tree, and we are given a start value and a destination value. And what we have to find the path, the shortest path between the start value and the destination value. So in this one, we have a start value as 3 and destination value as 6. So this is going to be our shortest path. If you see another one, okay, this though shows nothing, but nevertheless, and all the values in the binary tree are unique, so we won't have any trouble to find, because we are not given the nodes, we are actually given the values. So first we have to find the nodes, and then we'll see how are we going to solve it. So prior that, if we try to think like it's a binary tree and we are given 2 nodes, so how can we establish the shortest distance between them? How can we establish the shortest distance between them? So shortest distance has to, right? Shortest distance between any 2 nodes has to go with via their LCA. What is LCA? Lowest common ancestor. If we imagine there's a tree, which is like very huge tree, right? And we have to go from one node to another node, right? They had to be connected through at least a single, they would share a single common ancestor, right? They're bound to have it. Why? Because each node has a parent, and each parent again has another parent, and eventually they both have if not then at least one root node, which is their common ancestor. But there could be a possibility, let's say if we have in this diagram, example 1, assume that there is a big tree on top of it, and somewhere this is like maybe some branch and 3rd or 4th level, we have something like this. So even if we backtrack it till the very start, they will have a root as their common LCS, common ancestor. But 5 is going to be its least common ancestor. So for the shortest path, we have to first find its least common ancestor. Once we have its least common ancestor, once we'll find it, then what we have to do? Then it's pretty straightforward. What we'll do, we'll derive the path from the least common ancestor to the start value. We'll derive the value from the least common ancestor to the destination value. So we'll have this path 3 to 1 to 5, and similarly for 5, 6 to 2 and 2 to 5, right? From root to child, we'll use the algorithm which we have already seen. We'll travel from the root to child, we'll get the path, and we'll just rename the path as per the given instructions. So we'll see as we go in the coding. First, our job is to find the LCA. So let's do tree node LCA, right? Find least common ancestor. We'll pass the root, and then we'll pass the start value and the destination value. All right, let's make this function private static tree node. It will return the node, find LCA, and tree node, the root, then start, and let's send test. Okay. So somehow if root is equals to null, in that scenario we'll return simply root, and then we'll try to see if root dot value is equals to, let's say, start, and root dot value is equals to destination. Then this is my let's see. If not, then we'll try to go on the left and go on the right. So tree node left First to find LCA, not left, start, destination, and tray node right, find LCA, road dot right, start, destination. So if left is not null, and also, okay, not like, no, let's not let them do like this. We'll do something like, or if root dot value is equals to start, or root dot destination, not destination, root dot val is destination. So return the root. So it will try to find out. So it will just return those things. And if left is not null, and when the right is also not null, so this is the common one. So we'll just return root. If not, then return, if left is not null, then return left or else right. So this is already a very simple one. So we'll find the LCA, this common ancestor, and it's there. Now what we have to do, we have to find the path. So we'll create, let's say, string buffer SB string buffer. Let's take it as path 1 and record find path root and then start value. Let's make the find function path also private static. So the LCA, right? Find LCA. How does it actually works? Let's say we started from here, and it tries to check if it's matching the start or the destination. So it's not matching actually. So it will try to go to the left one. So we'll call the function find recursively for the left node and the right node. For the left node, it will again try to see if it's equals to either of them. So it's not. So again, it will try to call the left one. Right. So this is actually equal. So it will return nothing but the root. So it has returned 3. Right. So similarly, this will also return 3. So it has actually returned 3. And if you go on this side, now it will call the right section. And this one again will it will call the left one and the right one. So first the left one. So again, we reached at 6. Okay, so 6 is actually equal. So it will return 6. And eventually this will also return 6. Right. So since it has returned 5, it has returned 5. So both are actually not null. So this has both the, from the left side and the right side, it got something. Hence, this becomes our LCA, the common ancestor for both the values, right? And somehow if it was null, so it would have returned null, so it wouldn't have been the LCA. So we'll keep on like recursively finding further depth, and eventually it will find if there is any. Now we'll have to find the path. So we'll just do this. The Boolean and let's avoid find path it string buffer SP unknown. But also pass the value path when right. So over here we'll have to end value. And let's say target. So we are passing the root node, the target, and the string buffer will store our path. So if somehow root dot value is equals to target, so we have found it. What will then? We'll simply return it. Return SB. Prior that we have to append it SB dot. Oh, there won't be any path, right? Because this root node itself is the target, so there's no path. So that's how, yeah. And then if root is, then we'll return the SB. If not, then we try to go to the left So what we'll do is, let's make it Boolean. So if find path root dot left target, and since we are going to the left, we'll do sb dot pen, or better to take it as sb dot append what? Since we are going to the left, let's append L. Right, so root dot left target, and this, if it's true, it will return true. True. Now that we have to remove the sp dot delete caret. At the very end, we have to remove so sp dot length -1. So we remove it. Now we have to see for the right one also. So since we are going to check for the right one, it has to be right. If somehow it's true, then it's true, right? And if nothing is there, then we'll return false. Alright. So we got the path 1. Similarly, we'll have the path 2 also, where they will have to check for the destination 2. It will be path 2, path 2. So we have the paths. So if we try to see, right, system dot out dot print ln path 1 dot to string, and similarly path 2 dot string, how they actually look. So this will be like 513, right? So it will be like LL, and this should be nothing but right and left. Let's see. Okay, 43. Something is missing. Root in, okay, train out, right? Oh, it should be fine, I think. Spelling string buffer. Run it. Like a null pointer exception, where actually it's at 45. Okay, if root equals to null, return false. Right, so we got LL and RL. So LL is like from 5 it went to left and then to left, so we found 3, and if from here it went to right and then finally to left, so RL. That's what we received, right? LL and RL, right and left. And if we say the test is 2, just the left, because and that one, right, the start is root itself, so the path 1 is nothing but empty. So what we have to now do, since we have the paths, if you see, this part is fine. From the path 2, from the least common ancestor to the destination, that is perfectly fine. But this, right, the path 1, it needs to be converted to, because we are coming from top to bottom, right? So left, right, left, right, left, right. But in the moment when we visualize, right, we have to go from the bottom to up, everything will be converted to U. Because it says like irrespective of left and right, if you're moving from the node to its parent, it has to be U. So what we'll do when we are going to return the result, we'll simply do path 1 to string, right? Then replace all, we'll replace everything with U. And then we'll append path 2 to string, And this should do, right? This should be our answer, because we have replaced everything in the path 1 to U, and path 2 will be as it is. Let's comment it out. We don't want to print these. And let's submit it and see. Okay, somewhere it failed. If we try to visualize this one, use test case. See the graph. All right. Start value is X. Destination value is 15. And if we try to print the path, okay, 6 and 15. So their common ancestor is nothing but 10. Is it? I see system dot print ln LCA, right? LCA dot val. Let's run it. Perfect. So we are getting the least common ancestor as 10 only. That's right. And from 10, its start value is nothing but right. Why right? No, it's not right. Oh, okay, right. So what the problem is, we had to calculate the path from the least common ancestor, not from the root. So these we have to change it, right? Find path. It has to be LCA, and not try to run. This should resolve it. Yeah, this did resolve it. I'll just comment out these print sections and submit it. So that was the problem, the find path. In the find path, we have to calculate the path from the least common ancestor. And it's done. So in short, what we did, it's more like a combination of two questions where we have to find the least common ancestor. And then at the same time, we have to utilize the concept of path from the root to child. Once we have the path, once we have the least common ancestor, we'll calculate the path from the least common ancestor to the root, to the child, the actual given nodes, and then we'll just convert the path 1 with a upside, because we are coming from the bottom to up, from start to destination, so it has to be up, irrespective of left and right, everything will be up, and path 2 will as it is, so we have returned it, and that's all. This is our answer.